Good morning, guys. As today we are starting through the diploma of electrical engineering, the syllabus for semester 2 for fundamentals of electrical engineering as per MSBT course code 312310. Now we are going to learn the unit 1 basic electrical parameters, and accordingly I will teach you the DC current, direct current, alternating current AC, voltage source and current source, and their ideal and practical, electrical current, electrical potential, potential difference, electromotive force, EMF, electrical work, electrical power, and electrical energy, definitions and their expressions, resistance, resistivity, conductivity, effect of temperature on resistance, types of resistors and their applications, heating effect, magnetic effect, chemical effect of electrical current, and so on. For the first unit 1, we have to at least cover it in 2 or 3 lectures in our upcoming videos. Now we are going to start with it. Fixed resistors. Fixed resistors will be having fixed resistors. Fixed resistors are of 3 types, mostly carbon film resistor, second is metal film resistor, third is wire wound resistor. Now I will be discussing the applications. Carbon film resistor is used in electronic circuits, which is cheap. Carbon film resistor is used in electronics, and it is cheap. Now, as we are going through metal film resistors, high accuracy used in measurement instruments. It will be used in measurement instruments due to its high accuracy. High accuracy used in instrumentation, you can see, or measurement systems. High accuracy. Now, wire wound resistor. Wire wound resistor are actually high power rating used in heaters. As you will be seeing your household heaters, that will be provided with wire wound resistors. Heaters providing high power ratings. It is nothing but I square R loss to generate heat. It is nothing but I square R loss to generate heat with respect to time. I will be teaching you further. The same thing will be explaining. Now, variable resistor. Variable resistor is nothing but variable resistance or resistors. It is nothing but potentiometer. Potentiometer and rheostat. Rheostat and potentiometer. Potentiometer, you can say, it is nothing but a variable resistor which is used for controlling the speed of fan. It is the basic function of it. It is nothing but a pot, the round pot it is, and it will be provided with the resistance in this scenario, and here they will be having tappings, different taps, and these taps will be nothing but resistance. This will be R1, this will be R2, this will be R3, this will be R4, and so on. As per this, they will be taking first this resistance into system. It is nothing but a low resistance. That's why the resistance is low, the speed will be high. The resistance low, speed will be high. Once you start taking these in series with it, R1, R2, R3, R4, R4 will provide the lowest speed. This is the operation of pot variable resistance. Same way it will be helpful in variable sound system also. The same concept will be used in variable sound system. Now what is rheostat? Rheostat is nothing but a variable tapped resistor which we will be using in controlling the motors, controlling circuits, motor circuits, generators, in somewhat batteries also we are making it use. Even varying currents in labs also. Now what is LDR? Just now I told you LDR is nothing but light dependent resistor. LDR is nothing but light dependent my handwriting is a little bit light dependent resistor, LDR. In this, resistance is inversely proportional to light. Resistance is inversely proportional to light. You can say when your light increases, resistance decreases. This is the one property of light dependent resistor, which is heavily used in street lights, automatic lights, varistor. Now after LDR you can say varistor. It is nothing but a surge voltage, protection from surge voltage. As you know, we have started our lecture with source voltage, means how the ideal source will be. The voltage will be having the zero resistance, somewhat thing we have already spoke. The same way, surge voltage is nothing but a spike of voltage, means it is just like this, the spike of voltage with respect to time. For a very short time, the voltage surge takes place. And this voltage surge or this spike can be reduced with the help of resistor. What resistor does? Resistor will be connected to reduce the I square R loss will be the power dissipation which will reduce this spike. Means this spike is very harmful to our system because our insulation level is designed for a particular voltage level. Means our machine is designed for 33 kV, and if this spike comes for about 50 kW for fraction of second, it will destroy our system if it remains for a prolonged time. That's why we have to nullify this voltage in terms of power dissipation. This power will be dissipated across the resistance, and that's why this spike will be reduced. This spike will be made to the normal. That's why we are using this varistor. Now I will be explaining you the effects: heating effect, magnetic effect, heating effect, magnetic effect, and chemical effect of electric current. Now heating effect is nothing but, I have explained earlier also, the I square R loss, power dissipation loss for a particular time period. It will generate heat generated by I square R into T. It is nothing but watt second joules. This is power dissipation. Power dissipation. The power which is dissipated across the resistor. This is I square R. And due to this, it will generate a kind of heat, as it is, this power has been dissipated for a particular time period. That's why the heat is generated. When current flows, this heat is produced. The applications are room heater, you can say iron, electric iron, room heater, geyser, electric fuse. As current flows through any kind of conductor, the conductor will get heat up. Now we will be dealing with magnetic effect. When current is flowing through a conductor, it produces a magnetic field. This is a conductor. Now this current is flowing through it. When you apply some sort of voltage across it, this will be creating a magnetic field across it, and these magnetic fields will be in different directions. It will be creating north and south pole accordingly. And this is nothing but a kind of example of solenoid also. It is nothing but a long length wire which is been magnetized when current is applied to it. The applications of those are motor, generator, solenoid. Just now I have explained you. Even the transformer also, because in transformer it will be having two coils. This will be electrically separated, but this will be magnetically connected. This is nothing but a conduction, mutual induction effect. This is nothing but a mutual induction effect. I will be showing you when I will teach you the magnetic circuit. Now, chemical effect. Principle of electrolysis principle. This is based on the chemical effect is nothing but when an electric current is applied through electrolyte solution, when it is separated by anode and cathode in this flask, when these are supplied by a anode and cathode, this will be the solution. This is anode and this is K cathode, and here we will be applying a voltage this is the resistance, and the current will be flowing in this manner. And as the current flows through it, it will create a chemical reaction. These chemical reactions are created by applying electric voltage to it. And when you apply electric voltage to this solution or this circuit, you will see that current will be flowing through this anode and cathode, and through the electrolysis principle and electrolysis process, the chemical reactions will be created, and accordingly some part of chemical will be exposed to environment, or in this solution you will be seeing some sort of hydrocarbons and all. Electroplating is the process, electrolysis, battery charging, aluminum extraction, all these are types of those process. And actually mass is directly proportional to charge in chemical effect. Mass is nothing but mass is deposited when charge is flowing through it. Now you can say mass equal to ZQ, and Q, you know, Q is nothing but IT. Q is nothing but IT. I have explained it. The charge is nothing but a current flowing in a particular time period, for a particular time period. M equal to ZIT. This is the final solution. In this, Z is nothing but a electrochemical equivalent. Electrochemical equivalent. Z is electrochemical equivalent. It is nothing but Z will be. Now from this equation you also can find what is the Z actually. Z is nothing but mass divided by charge is equal to Z. Now mass will be in grams, Q will be in coulombs. That's why G per C will be the unit of Z, the electrochemical equivalent. Now by Faraday's second law, for same quantity of electricity, mass deposited is proportional to equivalent weight. Yeah, in this case you will be seeing that the equation will be same, M equal to ZQ, but here the value of Z will be E by F. E is nothing but equivalent. F will be the value of coulombs, means that will be in Faradays. Actually its value varies from 96250 to 96500 coulombs. The value will be for F, the value will be 96500 coulomb, and E will be equivalent weight. Now I will be showing you actually here. I will clearly write it as E is equal to atomic mass divided by valency. This is the formula for E. It is nothing but equivalent weight on that substance. It is the whichever element we are using in chemical process, means you can say the anode is made up of copper and this cathode is made up of silver or any rest material. You have to calculate this E with the help of atomic mass of that element divided by valency, which will be provided to you, and accordingly you will find the Z. Z is nothing but E divided by F. F means 96500. Now you will get the value of Z, and accordingly once you substitute value of Z, I will be given and time will be given in seconds. I will be in ampere. You will calculate mass. Even you can also calculate time from this equation as m divided by z into I. Or even in this equation also you can say m is equal to E divided by 96500 into I into T. This is the main equation for any chemical process or any electrolysis process where you can calculate any of these. The m is the mass, E is the equivalent weight, I will be the current, T will be the time in seconds. Now we have gone through a lot of concepts today of subject fundamentals of electrical engineering, the unit 1 basic electrical parameters, and I have already covered the all basic electrical parameters in this. Thank you.